let's name this molecule using the IUPAC system of nomenclature. I've gone ahead and redrawn it so that we don't have to worry about the Weatherman effect. Now to start, we can count that it's a 1, 2, 3, 4, 5, 6, 7, 8, 9 carbon chain. The question is, should we number it from the right or from the left? Well, with an alkyne present versus an alkyl halide versus a halogen, we're going to number so that the alkyne carbon gets the lowest number. As a result, we'll number this from right to left. And so let's do that. This tells us that our molecule is going to be a non-3-ine. Let's write the name up here. Non-3-ine, where the 3 tells us that the alkyne starts at the 3 carbon. We can next look at the substituents. So we have a methyl group at the 6 carbon and a chlorine at the 7 carbon. When we add these to the name, we're going to put the chlorine first because it comes first alphabetically. So the molecule will be, hopefully we can get the space to work out, 7-chloro, 6-methyl, non-3-ine. Are we finished? Not yet. These two groups have stereochemistry, and so we have to assign R and S at the 6 and 7 stereocenter. We'll do that. Let me switch colors to orange. We'll do that by prioritizing. Let's start with carbon 7 first. Chlorine versus carbon versus carbon versus hydrogen. The hydrogen is going to be number 4. The chlorine will be number 1 because it has the highest atomic number. Hydrogen has the lowest. When we compare these two, they are both carbons. This carbon has 1 carbon attached. This carbon has 2. So it's going to be priority number 2. Coming to the left is priority number 3. Our lowest priority substituent is back, and we're going in a clockwise direction. And so this molecule will be 7R. Now we still have to do it at the 6 carbon. I'm going to come down and redraw the molecule just so we don't have numbers overlapping. So let's at least look at the stereocenter at carbon 6 in this structure. So here's our carbon 6 stereocenter. We have carbon versus carbon versus carbon. They're all tied. Hydrogen is lowest. It becomes number 4. This carbon is attached to a carbon. This carbon is attached to only hydrogens, and this carbon is attached to chlorine. So that chlorine becomes the tiebreaker that allows this one to be number 1. The carbon attached to the carbon wins that tiebreaker, so number 2. This carbon, which is attached to only hydrogens, that makes it finish in 3rd. Our lowest priority substituent is once again going back as we count from 1 to 2 to 3. That is again a clockwise. So this is going to be 6R. Giving us the final name, 6R, 7R, 7-chloro, 6-methyl non-3-ine.